Despite the recent test failure, SpaceX is pushing forward with relentless determination, showing no signs of slowing down. The atmosphere around Starbase may appear calm on the surface, but deep within the company's operations, the groundwork for Flight 10 is unfolding with remarkable momentum. This isn't just another test flight, it represents a pivotal point in the Starship program, a mission loaded with expectation, engineering refinement, and a real chance to turn recent setbacks into a definitive leap forward. The countdown to this next mission is intensifying, possibly arriving faster than anyone had originally anticipated. If we step back and observe the landscape at Starbase, one might be surprised by how quickly everything is coming together. Key components, such as sea-level and vacuum Raptor engines, have already been spotted moving into Mega Bay 2, clearly designated for Ship 37. These engines are crucial to upcoming static fire tests and eventual launch, and their installation is reportedly imminent. While the exterior might seem quiet, the operations within are methodical and precise, as SpaceX engineers prepare to overcome past obstacles with refined strategy and technology. The static fire stand, in particular, has seen a flurry of activity in recent weeks. It's no longer just a testing platform, it's evolving into a flexible, semi-fixed setup capable of supporting a wide array of missions. The new design of the test stand, equipped with detachable support legs rather than welded ones, is a smart move that allows rapid repositioning and modular use for future launches. Recent modifications, such as the addition of mounting hardware, seem specifically intended to accommodate the unique dimensions and forces generated by the vacuum Raptors on Ship 37. This test infrastructure update signals more than preparation, it suggests scalability, foresight, and a readiness to iterate faster than ever before. With these components nearly complete, the platform is expected to be moved into position on the orbital mount soon. Once secured, it will undergo a series of validation tests, quick shakedowns to verify integrity and safety before welcoming Ship 37 for its critical static fire. This marks the first time a ship will be tested alone on this upgraded stand, but there is solid reason to trust its capabilities. After all, the same platform has already handled super heavy boosters, which generate significantly more thrust. If all continues to go according to plan, Ship 37 could be ready for launch within July. It's a stunning turnaround considering the magnitude of the Ship 36 incident. Critics had doubts, but SpaceX's infrastructure adaptability and resourcefulness are once again proving that no delay is permanent when progress is baked into your engineering culture. On the super heavy side of things, readiness is equally impressive. The only significant remaining task is the reinstallation of the hot staging ring, which was recently returned to the Star Factory. This part isn't expected to delay things by much, SpaceX's rapid integration procedures should have it reattached in no time. Altogether, it sets the stage for Flight 10 to be one of the most consequential tests in the Starship program's history. 3 major flights have already been conducted using the Starship V2 configuration this year alone. While each one offered valuable data, they also highlighted persistent challenges. Flight 7 and Flight 8 suffered from catastrophic failures during ascent, while Flight 9 made it further but was brought down by a failed payload door and eventual loss of vehicle control. These issues have largely been traced back to a series of system-level flaws, particularly related to leak points, vibration resonance, and avionics precision. Even Super Heavy, which had previously performed nominal landings, encountered new hurdles as the complexity of missions increased. That's why Flight 10 isn't just a continuation, it's a milestone. This is where all lessons from previous missions must converge. Every subsystem must work in harmony. For the booster stage, that means a flawless main engine cutoff, a seamless stage separation, and a stable boost back burn followed by a controlled landing. There's little room for miscalculation at this point. The Starship upper stage faces its own set of unforgiving tests. It must survive the dynamic stresses of ascent, maintain full control through the vacuum of space, deploy its payload door reliably, and endure re-entry without structural degradation. The aerodynamic flaps, heat-resistant tiles, and internal control systems must perform to near perfection to clear all objectives. The biggest spotlight, however, may be on the composite overwrapped pressure vessels, COPs. These pressurized tanks were implicated in the failure of Ship 36, and SpaceX has wasted no time in simulating potential failure modes. Recent tests appear designed to replicate the extreme stresses that caused those issues. Armed with this new data, engineers are likely already implementing structural reinforcements or software corrections to mitigate similar risks in Flight 10. And this is where things get truly exciting. If everything aligns, if the engines burn clean, the stages separate on cue, the flaps guide the ship safely back through Earth's atmosphere, then Flight 10 could mark the first fully successful demonstration of the entire Starship system. That includes ascent, stage separation, orbit, payload door function, re-entry, and controlled descent. In other words, this could be the flight that makes full mission success more than a theoretical ambition. It's hard to overstate how important this would be for SpaceX's broader goals. Starship isn't just a test vehicle. It's the foundation of missions to the Moon, Mars, and beyond. With the Artemis 3 mission approaching and NASA watching closely, every test now carries global implications. The performance of Flight 10 may well determine timelines, budgets, and international confidence in the future of American-led space exploration. Are you ready for Flight 10? Type 10 in the comments and let us know your launch date prediction. Ours is July 28th. Be sure to subscribe to stay locked in with every update from Starbase. The countdown has begun, and the future is roaring to life. Starbase has once again become the focal point of anticipation as SpaceX accelerates its efforts toward the most advanced evolution of Starship yet. One of the most eye-catching recent developments involves the arrival and vertical positioning of Booster 18's landing tank, a component believed to be part of the first V3 Super Heavy booster. Unlike previous versions, this tank appears to be solely dedicated to storing fuel for landing operations, marking a significant and strategic leap in engineering priorities. Rather than relying on a shared system for ascent and descent, this advancement suggests SpaceX is streamlining booster recovery with greater efficiency, targeting precision landings even under heavier payload conditions. With the V3 booster set to be much larger and more capable than its predecessors, separating its landing fuel from ascent fuel will allow for greater control during return operations. This change could be pivotal, especially as SpaceX aims for increasingly complex missions and frequent reusability. At present, Booster 18's integration is well underway. The landing tank has been delivered to the Mega Bay, and though the aft and forward segments of the booster are still being prepped, final stacking is likely just around the corner. The pace and scale of these upgrades speak to SpaceX's broader goal, to transition from experimentation to true operational readiness. Yet, Booster 18 is only the beginning. The V3 generation isn't merely a tweak, it's a reimagining of Starship's entire design. The booster top is expected to feature a refined hot staging ring and possibly even an updated grid fin layout, aimed at better aerodynamic control during descent. Meanwhile, the aft engine section is moving toward an open structure design, ditching the full engine skirt for improved thermal dissipation and maintenance access. As construction continues, each segment tells a story of lessons learned, failures overcome, and ambitions grown even bolder. Parallel to these developments, 6 V3 nose cones have been spotted within the Star Factory, confirming that ship upgrades are also moving ahead at full speed. Following the destruction of Ship 36, production space inside Mega Bay 2 has opened up, allowing for more streamlined assembly of new components. To support this surge in activity, a new work stand recently arrived on site, hinting at the accelerated pace expected over the coming months. If assembly continues without interruption, we may see the first complete V3 stack sooner than expected, followed quickly by integrated testing, perhaps even a test flight before the end of the year. This upcoming flight will be more than a technical milestone, it will mark the symbolic end of the V2 chapter and the start of an era shaped by precision, repeatability, and high-performance design. V3 is slated to become the new standard, especially for NASA's Artemis missions. It's this design that will carry humanity back to the Moon. And so, every weld, every new sensor, every bolt tightened brings that future closer to reality. These vehicle upgrades are mirrored by impressive progress in infrastructure. At the production site, foundation pile driving continues in the Gigafactory Bay Area, signaling the end of ground prep and the beginning of structural assembly. If foundation work wraps up as projected within weeks, the steel framework could rise rapidly. Once operational, Gigabay will function in parallel with Star Factory, forming a manufacturing powerhouse capable of building starships at an unprecedented rate. These aren't just buildings, they are assembly lines for the future of space travel. Meanwhile, the launch site is experiencing its own wave of transformation. Pad B is approaching completion, with all 20 clamp arms installed and the booster liquid oxygen quick disconnect backplate in place. The chopstick system has been temporarily lowered for cladding and other upgrades, hinting that full functionality isn't far off. Fuel infrastructure is expanding too, with new pumps being added to the tank farm to increase fueling efficiency. Most ambitiously, a new fuel production plant has been proposed to manufacture liquid methane and liquid oxygen on-site. If approved and completed, this facility would allow SpaceX to operate independently of external suppliers, a huge leap toward launch autonomy. Together, these efforts form a picture of synergy. Hardware design, production capability, launch readiness, they're all converging with unprecedented momentum. But what must SpaceX do to transition smoothly into the V3 era? The answer lies in the roles of the final two V2 vehicles. Ship 38 and Booster 17 are positioned to carry out Flights 10 and 11, two of the most important missions in the Starship timeline. Flight 10 is expected to address the technical hurdles uncovered in previous launches. These include engine reliability, payload door functionality, re-entry dynamics, and especially COPV stability. However, there will be no catch attempt during Flight 10. The priority is completing a full, stable two-stage mission that demonstrates the readiness of all core systems. Flight 11, by contrast, holds the potential for a groundbreaking attempt, a full booster catch using the Mechazilla arms. If successful, this would validate one of the riskiest and most ambitious components of Starship's reusability strategy. It would be the crowning moment of the V2 generation, proving the integrated recovery hardware and setting the stage for V3 to build on proven success. And even if it fails, the resulting data will be invaluable. To make these missions possible, Booster 17 has already completed cryogenic proof testing, and Ship 38 is reportedly fully stacked inside Mega Bay 2. Although ongoing COPV issues at Massey Station may delay cryo testing, this lull gives engineers more time to fine-tune systems and cross-check redundancies. Each moment counts as preparation for these final flights reaches critical stages. This is more than just a turning point, it's a handoff. Flight 10 is about confirming that the foundation is solid. Flight 11 is about reaching further than ever before. Together, they form a bridge between experimentation and execution. And while Starbase may seem calm today, the quiet won't last. In the weeks ahead, testing will resume, static fires will roar, towers will lift, and countdowns will begin. The march toward V3 is not a distant promise, it's an approaching reality. The hardware is almost ready. The infrastructure is primed. The knowledge is in place. All that remains is execution. And if there's one thing SpaceX has consistently delivered, it's the will to turn vision into velocity. This is Kevin with Great SpaceX. If you haven't already, make sure to subscribe and join us as we continue tracking the most exciting development program in aerospace history. Your curiosity, imagination, and passion fuel our mission. Keep looking up, because what's coming next will redefine everything we thought we knew about space travel.